Let's write our own stud function. But before I do, let me first introduce myself. I'm Jelle, I'm a C++ consultant, developer, and content creator, and the founder of C++ Doctor. How does stud function make it possible to pass in any object that overloads the function call operator? And the answer is with type erasure. It simply hides the type of your callable object using a combination of template programming and polymorphism. Let's write our own stud function. I'll just call it function. And we're going to simplify this a lot just to demonstrate the type erasure part. We're going to assume it's going to expect a callable that takes no argument and returns void. So let's say we just have a constructor that takes our callable function, and we're going to use template for this. So here t, it can be a lambda that's invocable, it can be just an object, basically anything that's invocable like this, so we can just invoke it. But we're not going to do this. We're going to use polymorphism to accomplish the type erasure. So let's say we have some interface, a base class. Let's just add a default constructor. But the most important thing is we need some virtual function that we're going to override later on. And this will call our function. Let's just call it call the function. And this is pure virtual. And this is also what we're going to store in our class. Our derived class will store this function. And so the derived class must be a template created in here. We have a derived class that inherits base. And this will be a template as well. Actually, we don't need to do this in here because we already have the t. So we can see a t function. And then we just override call the function. So we're going to create it here, and we're just going to assign a function. And then we're going to assign it to base. Our derived is a template struct with one member, the function of type t. Remember, this is a template constructor, but the class itself is just of type function. The class itself does not expose the type of the callable. Let's say this is just set the function. Now let's say we create an instance of our function f. Set the function. We could just set it to an empty lambda, that's fine. We can also set it to something that has state like x equals 0, or maybe even x equals a vector int. Probably need vector in here. We could have a custom struct, and we could say set the function. The compiler will create different versions of set the function, taking the different invocable types. Now in the end, you have just a function here, and the type of these objects is completely hidden, and these are stored within the derived class. So yeah, this is how type erasure works. It's used in stud function as well as stud any, and can be very helpful if you don't want to rely on polymorphism from the outside, because all these lambdas, this struct, they don't override some base class. Polymorphism part happens internally, but there is no base class needed from the caller side, and that's really helpful. If you've enjoyed this video, make sure to subscribe to this YouTube channel, as well as to my C++ newsletter, where I share C++ best practices and tips on a weekly basis.